blurry. Every image for 3 years from the most expensive telescope ever built. Beaten by a manufacturing flaw 1/50th the width of a human hair. And here is the part that should keep you up the night before the exam. That flaw was catchable on the ground for almost nothing. Nobody caught it, and it turned into one of the most expensive repair jobs in history. By the middle of this, I'll hand you the single question that answers almost every quality item on the exam. And it is never, did we inspect it hard enough? File that away because it is the whole shift, and if you only take one thing from today, it should be that question.
Surprised is the right reaction, by the way. Hubble reached orbit with its main mirror ground too flat at the very edge by about 2 microns. 2/millionths of a meter. And here's the maddening part. On the ground, 2 separate measuring devices flagged that something was off. Somebody trusted the third device instead, decided it was the authoritative one, and filed the disagreement away in a drawer. So the fix flew on a space shuttle in 1993. Astronauts, a robotic arm, corrective optics the size of a refrigerator, an entire mission built around giving the telescope a pair of glasses. Hundreds of millions of dollars in orbit to correct a mistake that a second look on the factory floor would have caught for the cost of one careful afternoon.
And what gets me is how small the miss was. 2 microns. You could line up 50 of those errors across a single human hair, and that rounding error blinded a billion-dollar telescope for 3 years.
That is the whole domain we are standing in. We are deep in the process domain now, the biggest slice of your exam, and this is task 7. Read the title slowly because the verbs are the entire lesson. Plan and optimize quality of products and deliverables.
And notice what that title does not say. It does not say inspect quality. People hear the word quality and picture the final check at the end of the line, the gate at the loading dock, the person with the clipboard. The exam means something that happened much earlier, in a quieter room. It means the plan that made the defect unlikely before anyone built a single thing.
So the sentence to carry into the exam is, quality is planned in, not inspected in.
Exactly that. You cannot inspect quality into a product at the end. The inspector does not add quality. By the time a deliverable reaches that inspector, its quality was already decided upstream, in the design, in the process, in the plan. All the inspector can do is tell you how much of it is already gone.
Which is exactly why experienced managers get quality questions wrong. In the real world, you run a project, something feels shaky, so your gut says add another round of testing, add another inspector, tighten the gate at the end so nothing bad gets out. That instinct feels responsible. It feels like leadership, and in a status meeting, it sounds great. And on the exam, it usually scores wrong, because you just spent more money to find the same defect later instead of spending less to stop it earlier.
Because more inspection at the end does not remove a single defect. It only finds one that already exists, later, when it costs more.
Right, so let me give you the frame the whole task hangs on, the one PMI actually tests, over and over, in different costumes. It is called the cost of quality, and it splits cleanly into 2 halves. Money you spend on purpose to get it right, and money you lose when it goes wrong. Learn to see any quality scenario as a question of which half you are funding, and the answers start to line up.
The first half is the cost of conformance, the money you choose to spend to conform to the requirement. It has 2 buckets. Prevention, which is training your people, building the right process, doing the design review, buying the better tool, all the work that stops the defect being born. And appraisal, which is testing, inspecting, and measuring to confirm you actually got it right.
And the second half is the cost of non-conformance, the money you lose because it went wrong anyway. 2 buckets again. Internal failure, defects you catch inside your own walls, so scrap and rework, and the schedule you blow redoing it. And external failure, defects the customer catches, so warranty claims, recalls, lawsuits, and the trust you spend years trying to earn back.
And the shape on that board is the whole lesson. Do not memorize the 4 words, read the picture. The cheapest dollar in the system is prevention, at the top. The most expensive is external failure, at the very bottom, the one the customer finds for you. And the fall is steep, not gentle. Some studies put it near 10 times more expensive at each level, so $1 of prevention, 10 of appraisal, 100 of failure. The numbers are illustrative, but the direction never changes.
Hubble is that stack made real. A prevention dollar, a technician taking that measurement disagreement seriously on the ground, would have been almost free. Instead, the same flaw slid all the way to the bottom of the stack and became a crewed shuttle mission. Same flaw the whole way down. The only thing that changed was how late they caught it, and the price climbed with every level.
So the exam is not testing whether you know the word quality. It is testing whether you spend your money at the top of that stack or the bottom. And the experience instinct, add an inspector, tighten the final gate, spins it right in the middle on appraisal, catching defects instead of preventing them.
So build one reflex before we go further. When a scenario mentions quality, your first mental move is not, how do we catch it? It is, how do we prevent it? Prevention first, appraisal second, failure never on purpose. Say it until it is boring.
Quick gut check before scene 2. On that stack, which single dollar is the most expensive one you can spend on quality?
The external failure dollar, the defect the customer finds, every time, and it is not close.
And that is the reframe. Prevention is not the cautious, slow choice everyone treats it as. It is the cheap one. The reckless, expensive move is to skip it and quietly let the customer do your testing for you. Everything we drill on this channel you can practice free at certs.professorerica.com. Free practice questions and free flashcards built for this exact exam. And the 4 cost buckets memorize a lot better on a flashcard than in a panic. Go break your instincts there before the test does it for you.
And keep that word inspection in your head, because in the next scene it is going to trip half of you on 2 distinctions the exam absolutely loves to swap. Bringing in a guest to help us take them apart.
Quick, honest ask while we are here. If this has been worth your time so far, hit like, then subscribe and ring the bell. I know everyone asks, but this one is free, and it is how a small channel like this actually grows. Professor Bergman is here to help us work through the 2 words the exam swaps most. Start us off.
The first pair is quality and grade, and people treat them as the same word. They are not. Quality is conformance to requirements. Grade is the category of features and functions. Grade is how fancy it is. Quality is whether it does what you promised.
So a cheap thing can still be high quality?
A cheap plastic bucket can be high quality. It holds water, it does not leak, it meets every requirement asked of a bucket.
Low grade, few features, but high quality.
And here's the rule PMI wants you to know cold. Low grade may be perfectly acceptable. Low quality never is. A basic phone with 3 features and 0 defects is a good product. A luxury phone that catches fire is not.
So on the exam, if the answer scolds the team for delivering a simple product, that's probably wrong.
Usually, delivering low grade on purpose is a scope decision, not a quality failure. Chasing the defect is the quality job. Choosing the feature set is a different conversation.
Okay, grade is a choice. Quality is a promise. Got it.
Second distinction, and this is the big one. Quality assurance versus quality control. Professor, the one-line split.
Assurance is about the process. Control is about the product. Assurance is proactive, it prevents. Control is reactive, it inspects. Assurance asks, are we doing it right? Control asks, did we get it right?
Picture a factory. Assurance is designing the assembly line and training the workers so defects rarely happen. Control is the person at the end of the belt pulling the bad units off before they ship.
And we feed each other, right?
That loop is the whole point. Control finds a defect, then hands it back to assurance so assurance can fix the process that produced it. One tells you what broke. The other stops it breaking again. And on the exam, the answer that quietly fixes the process almost always beats the one that just catches and discards the bad unit.
And on the exam, which one is management mostly responsible for?
Assurance, and this is a real exam bias. Deming argued the large majority of defects trace to the process, not the individual worker. So the correct answer usually fixes the system, not blames the person. Punishing the operator for a process failure is almost always the wrong choice.
And this is not just us reading tea leaves. PMI put quality straight into the exam outline by name.
Read that middle enabler out loud. Manage cost of quality, in parentheses COQ, and sustainability. When a certifying body writes COQ into the outline by name, the stack Chris drew is not prep school theory. It is a named, tested skill you are expected to reason with, not just recite. And notice the last enabler on that page, implement continuous improvement, which tells you the task does not stop the day you deliver.
And Control has a toolkit. The 7 basic quality tools, you do not need to master them. You need to recognize them in a question stem.
Cause and effect diagram, the fishbone for chasing a root cause. Flowchart, to see the process. Check sheet, to tally defects. Pareto chart, the 80-20, to find the vital few. Histogram, to see the spread. Control chart, to watch a process over time. And scatter diagram, to test whether two things move together. 7. Flashcard everyone.
Give me the 2 I'll actually see most.
Pareto and the fishbone. Pareto tells you which few causes create most of your defects, so you fix those first. The fishbone helps you brainstorm why a defect happens, sorted into buckets like people, process, materials, and equipment. Together they answer where and why, and that is most of quality control on the exam.
Now let me put $1 on all of this, because the exam does. Picture a project manager we'll call Bianchi, a quality lead on a medical device firmware team, 11 years in. Bianchi finds a bug pattern, and she can pay for that same bug at exactly one of 3 moments. Watch what it costs at each. Prevention, up front, a code review and a test rig that stops the bug ever being written, $2,000. Appraisal catches it in testing before release. Internal failure, $20,000 in rework and a slip date. It ships and the field finds it. External failure, $2 million in a recall.
2,000 versus 2 million for the identical defect.
Identical. The only variable is when she catches it. That is why prevention is the cheapest dollar and why the exam keeps pointing your hand at it. Think of prevention as a smoke detector and failure cost as the fire truck. The smoke detector is $10 and a Tuesday. The fire truck arrives after the house is already gone.
And nobody brags about the smoke detector. It's the quiet $10 that never makes the news.
Which is exactly why real projects underfund it. Prevention is invisible when it works. There is a famous $11 version of this. Ford, 1978, the Pinto.
A fuel tank design that could rupture and catch fire in a rear-end crash. Ford recalled 1.5 million cars, and the fix per car was about $11.
$11 a car upfront was prevention. The recall, the lawsuits, the name dragged through court for years. That was external failure, the most expensive dollar on the stack, paid at full retail price.
$11 a car. That is what the fix would have cost. They shipped it anyway. So here is the question I promised you at the top, the one that answers almost every quality item on the exam. Erica, land it for us.
Let me fix the question first, because most people bring the wrong one. The question people carry into the exam is, how do we catch more defects? That is the wrong unit. The exam is asking something else. How do we make the defect not happen in the first place? Prevention over inspection. Every single time, on question after question, that is the hand it wants you to reach for.
There it is. That is the question I held back at the top. And notice it is never about testing harder or adding one more reviewer.
And that is the small version. Stack the root cause rule on top, and it gets sharper.
So, do the root cause rule properly. When a defect shows up, the experienced move is fix the defect, ship it, move on, feel productive. What does the exam want instead?
Fix the defect and then ask why the process let it through, and fix that too.
Exactly. One broken part is a control problem. A process that keeps producing broken parts is the assurance problem sitting underneath it, and that is the one actually worth your afternoon. Patch the part and the process bites you again next week with a new serial number and the same root cause. On the exam, that is the tell. If the correct sounding answer only fixes this one instance, look for the answer that fixes the reason it happened.
Here is the most famous version of not doing that. 1999, NASA loses a spacecraft at Mars.
The Mars Climate Orbiter. $327 million gone because one team's software worked in metric newtons and another team fed it imperial pound force. Nobody reconciled the units. The orbiter flew too close to the planet and the atmosphere tore it apart.
And that is a pure quality process failure, not a genius failure. Brilliant engineers, one missing check.
Right. The units mismatch was catchable on the ground with a single reconciliation step, an appraisal that cost almost nothing. It became a $300 million external failure because the process had no place to catch it. The people were fine. The process had a hole where a check should have been. That is the pattern the exam wants you to see, over and over, in 100 different costumes. Prevention and appraisal are never glamorous. A units check. A second measurement. A design review nobody remembers. Deming built a whole philosophy on that quiet work, and Crosby wrote a book literally called Quality is Free, because prevention pays for itself the first time it stops a failure. The upfront cost is really a discount on the disaster you did not have.
400 to 1. That's your Bianchi ratio, right? 2,000 to prevent versus the recall. So the honest exam move is just spend everything on prevention and never stop. Cheapest dollar, so buy a billion of them.
And that is the trap on the other side. Read the title one more time. It says, optimize quality, not maximize it. You do not pour infinite money into prevention either. And an answer that says test everything twice and inspect it a third time can be just as wrong as skipping quality altogether.
This is the honest limit, and the exam tests it. Past a point, another dollar of prevention buys you less than the dollar of failure it would have prevented. Chasing zero defects on a low-risk deliverable is its own kind of waste. It even has a name, gold plating. Polishing quality nobody asked for is a defect too, because you spent budget and schedule the requirement never called for, and the exam dangles that generous-sounding answer specifically to see if you take the bait. The disciplined answer, deliver exactly what was agreed, feels almost too plain to be right.
So it is not spend nothing on prevention, and it is not spend everything, it is optimize. Match the quality effort to what the requirement and the risk actually need. There is a sweet spot, and both sides of it are wrong.
On a heart monitor, you push prevention hard because external failure is a human life. On a throwaway internal report that 3 people read once, you do not build a Six Sigma pipeline for it, and if an answer choice tells you to, that is the wrong answer. Read the scenario for the cost of getting it wrong, and the stakes in the STEM, choose your answer.
And when it does go external, the number is brutal. 2016, a phone with a battery that could catch fire.
The Samsung Galaxy Note 7, 3.1 million devices recalled. Banned from planes, discontinued entirely. This is Samsung's own estimate of what that defect cost them. Watch it climb.
$5.3 billion on a defect that lived in the battery, which is to say in the design and the supplier's process, long before a single customer ever opened the box.
And the lesson repeats across every one of these. Hubble, Mars, the Note 7, nobody in the room was careless. Leapfrog was catchable early and cheap, and the process simply was not built to catch it there.
That is the failure the exam tests, not the human mistake. The missing prevention that would have made the mistake harmless. So carry the reflex out of here. When quality shows up in a STEM, you are not measuring the defect. You are measuring whether the process is...
Because you're measuring the wrong thing if you only count defects. Look. The wrong thing being the defect count alone. If you only tally defects, you are standing at the end of the line with a clipboard, and the process upstream keeps quietly handing you more. Professor Bergman's back with us to close the task out. Count the process, not just the parts.
And task 7 has 3 more enablers people skip right past, all sitting in that same outline, and every one of them is fair game on exam day. Regulatory compliance, cost of quality and sustainability, and continuous improvement. Miss them and you have studied 2/3 of a task.
Sustainability in a quality task that feels bolted on to score points with a trend.
It is not bolted on. PMI put it in the same breath as cost of quality on purpose. Sustainability is now a quality dimension, a deliverable that meets its spec today but poisons a river or burns power it never needed, has a quality problem measured over a longer horizon. It fails a requirement, just a slower one. And the exam has started treating that horizon as fair game.
And compliance is the same shape: security, health and safety, regulatory. On the exam, a compliance requirement is not optional polish you add if there happens to be time. It is a requirement like any other, which means violating it is a quality defect. Full stop.
So project can be on time, on budget, delivered, and still be a quality failure because it broke a rule.
Exactly right. Conformance to requirements includes the legal ones. And think of the Tacoma Narrows Bridge, 1940. It met its build spec and still tore itself apart in the wind months after it opened, because a behavior nobody tested for was designed right into it. You cannot inspect that out at the end. You design it out at the start. It is the same lesson as Hubble, just built out of steel and wind instead of glass. And it is the reason planning quality sits at the very front of this task.
And the last enabler closes the loop. Implement continuous improvement. Kaizen. You do not just hit the quality bar once and stop. Every defect you find is fuel for a small, permanent improvement to the process, so the next round starts higher than this one did.
That's the plan, do, check, act idea, right? The wheel that keeps turning.
That is exactly it. Plan a change, do it small, check the result, act on what you learned, then turn the wheel again. Improvement is not an event, it is a habit the process carries.
So the whole task is really 4 moves, in order. Plan the quality, gather the requirements and pick the tools, assure the process, control the product, and improve so the next round is better than this one.
Now, that number I promised you back in scene 2, the one on a control chart that tells you a process is breaking before a single part ever fails inspection. Liam, wanna guess it?
No idea. What's the number?
7. It is called the rule of 7. On a control chart, if 7 points in a row land on the same side of the center line, even if everyone is still inside the limits, the process has drifted. Pure random noise almost never lines up 7 times running on one side. That is not luck, it is a signal, and you investigate before anything actually fails.
Wait, nothing failed, everything's still in spec, and I'm supposed to stop and act? That feels paranoid.
Stop right there. That's exactly the reflex the exam is checking. That's my lane for a second. In spec is not the same as in control. Specification limits come from the customer, the line they will accept. Control limits come from the process itself, its own natural voice, how much it varies when nothing is wrong. 7 points marching one direction is the process whispering that something shifted. A new supplier, a worn tool, a tired late shift. You fix it now, cheap, while everything still passes. That is prevention catching a failure before it is even born, and it is the exact opposite of paranoid. It is the whole domain compressed into one rule.
Okay, in spec versus in control. That one actually lands, and I hate that it makes me want to redo my old dashboards.
That is the smoke detector again. It goes off while everything still looks fine. That early warning is the entire value of it.
So let me leave you the drills, quick, exam style. First, your team finds a defect in testing. Do you A, fix it and move on, B, fix it and add 2 more testers, C, fix it and find why the process let it through, or D, escalate straight to the sponsor?
C. Fix the part, then fix the process. Prevention over inspection. Adding 2 testers is just more appraisal, and escalating a routine defect skips the work you are being paid to do.
Second, a stakeholder wants you to add extra polish beyond the signed spec, just to be safe. The quality move?
Don't M the 10 phase. Quality is conformance to the requirement, not more than it. You optimize to the spec, you don't gild it and call it care.
Third, a control chart shows 7 readings in a row below the center line, and every single one is still inside spec. Act or wait for one to fail.
Act. Rule of 7. The process has drifted, and waiting for a part to actually fail is choosing to pay full price at the bottom of the stack instead of pennies at the top. 7 readings leaning one way is the cheapest early warning you will ever get, so you take it.
Professor Bergman, the prevention over inspection framing is the single thing I want people to walk out of here holding. Thank you for that.
Seconded. The units check line reframed the whole thing for me.
Glad to help.
And the ruling, if you forget every tool and acronym we named today, quality is planned in, not inspected in. Spend at the top of the stack, prevent the defect, optimize the effort to the risk instead of maximizing it, and when one slips through anyway, fix the process, not just the part. Do that, and half the quality questions on this exam answer themselves before you finish reading the options.
Prevention over inspection. Simple enough that I might actually reach for it in the room instead of freezing.
If this finally made cost of quality click, hit like and subscribe. It is how we keep building this whole path to the exam, one task at a time, and it genuinely helps the channel more than you'd think. So here's the one I'll leave you chewing on. What's a defect that shipped in your world because someone chose inspection over prevention, and what would the fix have cost up front? Study the mindset, not just the tools, and I'll see you at the next task.